Thank you very much. Good morning, everybody. So I want to thank also Teledyne RESON because he invited me here to make this presentation. So what you're going to see here is a little bit different presentation compared to everything that you've seen so far. I mean, you've seen only data set from the bathymetry. So what you're going to see is the integration between different Teledyne technologies. And in particular, I'm working directly for Teledyne Optech. It's a company that we're based in Toronto, Canada. Teledyne Optech makes laser scanners. So we do everything that basically can survey from the water level above. So and that's why it was actually a very challenging application, and I find new application integrating new technologies with the bathymetry system. So Optech has different offices in US and Europe and China, and especially the office in the Netherlands. We've been working directly with Teledyne RESON for the installation of the integration with our technology and their technologies. Now, I want just to spend a few words about the history behind the integration between the laser scan and the multibeam. So, of course, you know better than me, for sure, what is this? So it's a SeaBat from Teledyne RESON. So you know how the SeaBat works, and it created I mean, the first time I've seen this data set, I was really surprised because it looks like a laser scanner data. So that's my background. So it just create really beautiful point cloud. You have every very fine details of whatever you see on a SeaBed. Of course, you just see that you got very nice data set, but you have nothing on over the sea level. So this is an example of what I'm talking about. So this is, that's the Wavebreakers. So very nice details. I've seen these data set with our software, and you got you see every single stone, very nice. And this is basically this is exactly what they scanned. But what you have, you just miss a piece of the there is something that you really miss. And this is exactly what is on top of the water. So what happened a few years back, back in 2007. So we have a few clients that they start contacting us and asking to have a complete integration between the data set. So we started with that was an example. So we started with a tripod laser scanner. So it was set on a fixed location. So you set it, you do the survey, and after you do the same thing with the bathymetry system, with the multibeam, and you got your data. So in this case, of course, it's time consuming because you have to do 2 surveys to get 1 result, and plus you have 2 softwares doing the processing. And after, to get this, you need to have a third-party software to integrate the data set. And the integration actually looks, the first time we did it was amazing. So clients were was really happy. The data set integrate perfectly, so seamless integration. You got all the information you need from here, from the bathymetry system. You got all the information from the laser scanner. Everything matched perfectly. Then, in the next years, we start doing other work. So our clients, just start using laser scanner more and more. You always setting scanners on a fixed location. In this case, we're in Venice. We're scanning multiple buildings for city modeling, and the result was including the 3D building with the bathymetry system. What happened is start opening different vertical markets, and one vertical market that was actually very, very good back in the 2007, 2008, 2009 was actually the bridge inspection. So again, you set the scanner, you got your bridge in 3D, you got your data set, boom, everything is your reference. So you got it's basically almost automatic, and you got the full point cloud. You can create whatever. So in this case, they needed to have the CAD reconstruction of the 3D building, the 3D reconstruction of the bridge, and the bathymetry as well. But the problem here was that it's not always possible to access fixed location, because, I mean, for doing this, you just need to set the scanner on a fixed location in order to be able to scan whatever you need to survey. So that's why we've been asked to develop like a mobile solution. So between 2009 and 2011, we started working with Teledyne RESON at that time, just to start doing the integration between the laser scanner and the bathymetry system. So we came out with like this is actually our platform. So you got your laser scanner, you sit next to the laser scanner, the Inertial system, you got 2 GNSS antennas, and basically you put this one on the boat, and of course you run the calibration, and boom, you're ready to go. So the scanner itself was able to create like new different works. Like one of the biggest one was the Quarry Survey, so the Quarry Survey. So in this case, of course, it changed completely the way to operate the laser scanner with the bathymetry system, with the multibeam. So in this case, it was actually a huge application, the Harbour survey. So they use a laser scanner and the bathymetry in order to, scan with the laser scanner whatever is over the water, and with the bathymetry, they usually tilt it 30 degrees, and they got like all the information on the quay wall. The result was really impressive. So we got like a few clients that they're still doing this kind of job, and they basically monitor in Europe. They monitor almost all the harbors. And the result, of course, you see like a seamless integration. What is surprising is that, and usually with the laser scanner you got like a million points very quickly. But if you check also on the bathymetry, the resolution you get is really impressive. And when you have everything combined together, it just, because now I color with 2 different colors, but usually you can also have the intensity, and everything looks like one single point cloud. Now, back in 2012, we've been working with the Teledyne RESON to integrate our scanner with the PDS 2000. That was the next step, because up to then, everything was manual. So you had to get your laser scanner, just do the integration. So once we start working with PDS, we actually found out it was actually very nice, because we can do the bore sighting directly in the software, and it was really nice to have the real-time viewer. So once you basically collect the data set, the software automatically can read. You can see here on the left, you have the laser scanner, and in real time you got your data set, and you have the bathymetry. You got the multibeam data directly in the real-time viewer. That was actually when Teledyne Optech was acquired by Teledyne. At that time, was a private company in 2012. So that's why we started working directly with Teledyne RESON, our sister company. Now, so up to now, what happened is when we started working with Teledyne RESON and other software, we just realized that. So our clients, they start opening different vertical markets, new vertical markets. So one, which was actually pretty big, was scanning the Wavebreakers. There's so many in the world, and I know there's a big requirement for surveying the Wavebreakers. But if you remember the picture that I showed before, usually if you have only the multibeam, you got the Wavebreaker, but you have no information on top. Here, you basically have the whole information. One other big application is actually the LNG terminals. So what you have now is that whenever the user scanned and surveyed the LNG terminals, they get all the information. They can use this information, in AutoCAD for the design of the terminal. And at the same time, of course, everything matched perfectly with the bathymetry. Now, one other application is the oil platform. With the laser scanner, you have a very fine details of whatever you have to scan. So in this case, this particular survey, we got like fine details of all the platform. I just learned yesterday because I didn't understand why we didn't get too many data set here. And Uni from RESON told me that, of course, multi-beam, when there is like iron, you can get like problems with reflections. That's why you got this. But again, also in this case, you still have like a very good combination between the data set. This is the wreck surveying. There are many, and we have one company that does only this kind of work. So what they do is, this is a warship in the Thames in the London, UK. So whatever you see in white, this is data set from laser scanner combined with the multi-beam data. Now, probably this is the biggest vertical market that we are at the moment. So it's just a short surveying. So what you have, of course, you can really understand. Just you got like multi-beam data set, all the shore from the laser scanner. This part usually it's not very useful, but of course you have information of everything that the laser scanner can see. But this is what usually the clients want to survey. We have in the marine and military, they use it a lot for all the surveying. You've seen yesterday in the presentation from Robert, the keynote speaker and CEO of Teledyne. There was actually a job that I've done the day after that there was this tragedy. So basically we've been there. So we surveyed the ship. It was an incredible work because basically I pass all the data set to the military because that's what they have to survey. They have to understand because the ship was actually, it was sinking, and it was lying on those rocks here. And the only way to make all these analyses was by integrating our Teledyne technology. The best part of this was that we actually all use all Teledyne equipment. So we use the Teledyne RESON for the multi-beam surveying. We use the laser scanner. We use a TSS for as an inertial system, and we use the PDS 2000 as a software. Now, there was a slide that you saw yesterday as well. This is actually, at the moment, we just say one family, two brothers, because we have the same, a similar technology, different application, but very similar technology. And the incredible thing is that, Teledyne Optech we build like airborne laser scanner, it's one division of our company, and we produce terrestrial laser scanner that can be used on on a vehicle or on the boat. So this is the application, of course, that could be interesting for you. Now, how the system works. So the system, so the way the system works, so we have to tweak a little bit the laser scanner in order to make the scanner be able to talk with the inertial system and the multi-beam. So it's very easy basically. So we have like this option is called motion compensation. So motion compensation basically enables the scanner to receive information from the inertial system. So once you receive the information, which is the timestamp, of course you connect the data set with the inertial system that gives the position and orientation and our data set. So as inertial system, we can use any inertial system. Usually normally we use a Planix, but of course we use also the Teledyne TSS, Orion. So inertial system, of course, both of them, they have like 3 gyroscope and 3 accelerometers, and the output is orientation and position. This is, a standard inertial system. Now, one important thing during our development was to have like something that it was like very easy to install, because at the beginning, back in 2009, it was really a long procedure, and calibration was long, so it was actually very quite complicated. So what was important was to create like something that was very easy to install, and that's why, I mean, we actually made the combination with the PDS 2000. So I mean, you know that. So the Seabed can be installed directly on the boat, or clamp on the right of the vessel. So on the right of the vessel. I've been told that usually this is the combination. Usually I've seen this one, like an old installation I've done. I just see this one once, but yeah, most likely it's like 40%, 60% of the time it's like this. Now, INSS, the inertial system, again, what we do, we have two different combinations. One is, if you use our platform, the inertial system can be installed directly on the platform, which is the best solution for us. I'm not sure if it's the best solution for the multi-beam, but this is basically connected. Everything is already connected, so we don't really have to do too much work on the bore siding. Or the inertial system can be already installed on the board, which is 90% of the cases. So it's you have to do the whole bore siding. GNSS, Aplanix has two GNSS. They work in RTK. TSS has only one. So, but anyway, so both of the two applications, two different inertial system can be used. So. So ILRIS 3D, the laser scanner usually looks one side. So basically you move towards one direction, you have the laser looking 90 degrees, scanning vertical lines, and you just do your survey. And so we have our stand, like our stand, or clients can actually create a customized stand. So it's either way. So most of the time they buy directly from us the platform. But I mean, for the application that we'll see after in Australia, the client actually built their own platform. So bore siding, that was actually the most tricky part at the beginning. So Teledyne RESON came out with a brilliant solution, I believe. So what they do is you need, of course, one object that you can scan for 4 position or 3 position, depends. Most of the time it's 3 position you can scan for 4 locations. So what you do is just you do one direction, you scan the object, you do the second, third, and fourth, and what you get is there are 4 different point clouds that in the PDS 2000 you have to align manually. So what you have is a pitch, yaw, and roll. This is the order I've been told that that usually operates. So you have like 3D point cloud here. You can rotate, and this is a 2D view. So basically, you just move the slide. You slide here, this bar, and you go to pitch. You go yaw and roll until the data set is connected together. So once it's connected, to be honest, it takes 5 minutes, 10 minutes. It's really fast. Basically, you have a result, which are the numbers here you can see, and this is basically a calibration of the laser scanner and the bathymetry. So everything in that moment is completely calibrated together. Result is, I mean, now I'm going to show you some images, but result is really, I mean, really nice. So you got like a seamless integration between the data set. In this case, you know, you can see the fine details of the multi-beam, and you got the data set from the laser scanner. So everything matched perfectly, and it's a really good tool, to be honest, also to check the quality of the two results, because whenever you have only one system, you have to trust that the geometry is perfect, so it's right. But if you have 2 systems with the same geometry, you're 100% sure that the result is correct. Now, going back to the Sydney Harbour survey. So what we did was back in the December 2014, we've been contacted by the Sydney Port Authority in Sydney, Australia. So what they wanted to do is they wanted to survey, in this case you can see here, this is the rock in, where there's the Opera House in Sydney. So what they wanted to do is to do the complete survey of the harbour here, the Opera House, the bridge, and basically this bay here and some parts over here. So in order to do that, what they have is they have like their own installation. This is the boat, as I said before. So some clients, they prefer to use their own platform, and in this case they built this stand. It was actually very good. It's the way we do usually. We send the drawing of our scanner, and whatever they built is I mean usually is fine. One thing that is important is to have like the scanner as higher as possible in the boat, because you have better view of the object that you want to scan. This is obvious, especially if you want to scan a shoreline. You need to be high so you have more data. In this case, what we did was we did everything in one day, which is very impressive. So what we did, we started at 10 a.m. With the mobilization and of the equipment. So we did all the installation, which takes half an hour. So we went out. We just did a bore sighting. So we start the survey at 12 o'clock, so at noon. So basically it took 2 hours, around 2 hours. We started the survey, so we surveyed 2 hours. I mean, we did like multiple passes, and we also did different other, so we tilted the multi-beam as well. Then, after 2 hours, we retrieved the data set from the hard disk, which is from the computer inside. So it's a lot of data, of course. 2 hours of survey from both bathymetry and laser scanner is a lot of data set that you collect. You do the processing. It took 3 hours, and at 5 o'clock everything was already calibrated. And the data set, I mean, we actually delivered the data set the day after to the Port Authority. Now, the result was actually amazing. We got basically the whole the rock, so all the harbour. What you can see, and something that I didn't mention before, you always see a little bit of gap between the laser scanner and the bathymetry data. In this case, we used, if I'm not wrong, the Seabed P50. So the aperture is 165 degrees. So of course so whenever you do the bathymetry, you just miss like some data set on top. So what we did, of course, what you can do, there are different way to do it. You can play with the tie, so whenever there's low tie or high tie, you can survey the missing point, or you can actually tilt the sensor head, the multi-beam, by 30 degrees, and you got this data set. And this is what we did in the next slide. So this is the other, it's another view of the Sydney Harbour. And this is exactly what I was talking about. If you really want to have like a seamless integration between the data set, I mean, that's what they do. Like they tilt it like 30 degrees the multi-beam, and this way the multi-beam can get data set up to the water level. Laser scanner can go under the water, so we have data set up to the water level, so there's nothing under the water. So, and basically we have the complete integration. So we did only this part because that was what the Port Authority needed. But of course, if you want to do like, you know, a second pass, you just do it, and you got your data. What you can see here is, this is the point cloud only from laser scanner. So as I said, we also scanned some areas outside the harbour here, and this is the big that's a bridge. So this is the last slide. I was when I put this slide, I didn't know what was this, and I thought it was a rack because that's the normal thing that you find in the under the water. So whenever you do like your multi-beam survey, but I was talking with Uni yesterday, and he said, no, that's not the boat. It's a car. It's a sport car. And I was really surprised because when I saw this, I was like, okay, so you see, it's probably, it just jumped from here, and it just landed here. And unfortunately, it looks like a nice car. I was really disappointed. Anyway, now just a few conclusions. So first of all, we just started like 10 years ago with using the laser scanner for shooting few points to define like a complete point cloud, like define like a complete, in one survey you can create like one single point cloud from below to above the water, and it was absolutely amazing. It was actually incredible to use like only Teledyne equipment. So we just create this Teledyne solution, which is actually clients are really happy. The installation is very easy, and calibration, so board sighting is very easy. And a nice thing, of course, is the real-time viewer that makes like something more. This is what I said before. So it's important because all the data sets is verified against each other. So before if you don't use the laser scanner, of course you trust that the inertial system did its job. The point cloud from the multi-beam is fine. But of course, if you combine two different sensors that they work in a different way and everything match perfectly, you're sure that there's no problems with the data set. The system, of course, is accurate. And the accuracy and the ability to survey on a huge area very quickly. This actually gives it gives a huge tool, an important tool to surveyors, and it has, of course, a great potentiality for a future, just to create new applications as well. And last is, as I said, the real-time viewer actually just gives actually something that before having that, the problem was that you go outside and you collect data set with the laser, but you're not sure that you collect everything you wanted. But now with the real time, you can check while you're surveying. You can check your data. You can stop the software. You can check if you collect whatever you wanted to collect before you come back to the office. That's it. All right. Thank you very much.
Questions, anybody?